Hi, I'm the math guy Steve. Let's try solving this equation. So when solving polynomial equations, we get 0 on one side, then factor the other side, set each factor equal to 0. Okay, now here, we already have 0 on one side. We could try factoring using grouping, but it doesn't quite work here. Okay, so then we have to use that rational zeros theorem, which says take the factors of negative 14 divided by the factors of 6, and just test them, because those are only potential rational zeros. Just test to see which ones work, okay? So we could test a bunch of different potential rational zeros. 1, -1, 2, -2. Then we try 7, -7. Actually, -7 ends up working, so let's try it. Okay, if I plug in, if I put -7 in the corner here, and then outside we put the coefficients 6, 41, -9, and -14. And again, if -7 does work, it is a 0 or a solution or a root, meaning the remainder is 0. So, all right, so we bring down the 6, and then multiply. -7 times 6, -42. Okay, adding, we get -1. Multiply, we get 7. We add, we get -2. Multiply, we get 14. Okay, add, notice we get 0. Okay, so this is one of the solutions to this equation. Okay. And then from there, we use, to find the other solutions, we use the rest of the coefficients, meaning 6x squared minus 1x minus 2 equals 0, okay? And now it's a lot easier equation to solve because it's a quadratic. So we could use a quadratic formula, completing the square, or we could try factoring using the AC method, okay? So here, A times C, 6 times -2 is -12, okay? And then what numbers multiply give me -12, combined to give me -1. We'd say -4 and 3, okay? -4 and 3. And so rewrite that middle term as -4x plus 3x, okay? So leaving the first term as it is, 6x squared, leaving the last term as it is. Just rewrite the middle. Now it's 4 terms. We factor 4 terms by grouping, meaning group these two. What's their GCF? What do they have in common? But notice they both have a 2x in common. If I take a 2x out of each, what's left? Just 3x minus 2. Okay, group these two. What's their GCF? What do they have in common? Well, notice they both have just a 1 in common. I'll take a 1 out of each. What's left? 3x minus 2. And notice they both have, looky. They got that 3x minus 2 in common. If I take the 3x minus 2 out of each, all right? 3x minus 2, what's left? 2x plus 1, okay. Now setting each one of those equal to 0, so 3x minus 2 equals 0, and 2x plus 1 equals 0. We get x equals 2/3, and then x equals -½ okay? So those will be our 3 solutions to this equation. Now, again, the good thing about this is that it's checkable, okay? When solving an equation, you just plug them back and plug it in to check to make sure you get a true statement, okay? So that's the Nike step, the check step, okay? All right, always remember, math is everywhere. Okay, I'm coming. Would you really need me?